Scientists have been telling us for some time that plastic rubbish is slowly choking our oceans, but new research shows it's even more of an international problem than previously thought. Rubbish collects in huge floating garbage patches in the middle of the world's oceans, and that's just what floats on the surface. Scientists have been exploring the sea floor and the insides of turtles to examine the impact that our obsession with plastic is having on our marine environments. Liam Cochrane reports.
At a Queensland research station, Kumar Schuyler checks out the latest suspected victim of death by plastic.
6.00.
This green turtle was found emaciated and covered in barnacles. Signs it could no longer dive to find food, possibly due to plastic in its gut.
And just here is another indication that the turtle's probably been starving for some time.
Kumar Schuyler and her team have looked at every study since 1985 that measured just how much plastic sea turtles were digesting.
For particularly the green turtles and the leatherback sea turtles, the incidence of plastic ingestion or the risk of plastic ingestion for these turtles has increased dramatically over that time period.
The long lives of sea turtles and their far-ranging migrations make them good test cases. Older turtles often mistake plastic bags for jellyfish, while younger turtles are more likely to accidentally eat small pieces of white plastic floating among their usual food supply. The results can be deadly.
Plastic can lead to death for the sea turtles through one of two ways. It can either impact the digestive system, making it impossible for the animal to process its food. It can also perforate the gastrointestinal system and allow fluids to leak out into the stomach and kill it slowly that way.
Even if the plastic doesn't kill the turtles, it can still cause damage. Some plastics are produced with harmful chemicals, while other types act as sponges for various toxins already in the ocean. These can lead to a build-up of poison in the bodies of sea creatures. Kumar Schuyler says what's happening in the stomachs of turtles has relevance for those further up the food chain, like humans.
Organisms as small as plankton are ingesting plastic particles, very tiny plastic particles. And as larger organisms eat those organisms, the amount of plastics in their system accumulates up the food chain.
The future of plastics is bright indeed.
Since the 1950s, the amount of plastic produced and thrown away has grown exponentially. According to a study by the European Council, plastic production has been increasing by an average rate of 9% since 1950. The peak production was in 2008, when 245 million tonnes of plastic was produced worldwide. Some estimate it takes a plastic bag 500 years to fully break down. But as plastic has only been around for 50 years, these are only guesses. But thanks to recent computer modelling techniques, we now have a much better idea about how plastic debris circulates.
Oceanographers like me have been deploying drifting buoys in the ocean for the last 30 years already, and we've been using these buoys to get an estimate of what the plastic does in the ocean. And we use the trajectories of these buoys to create this website, Adrift, where you can basically see if you throw your bottle in the ocean, somewhere like here in Sydney, how it would end in the garbage patches.
Scientists believe there are 5 big garbage patches in each of the subtropical oceans and a 6th patch in the Arctic.
A lot of people think about it as big islands of massive amounts of plastic, but that's not really true. It's much more small, tiny pellets, millimeter-sized pellets that drift, that float on the surface of the ocean.
But Eric Van Sebel's research has found that these garbage patches aren't isolated from each other.
So what we learned from our computer simulations is that the garbage patches are not the sinkholes that we thought they would be. In fact, they're much more connected. So plastic does get into the garbage patches, but on long time scales, 50, 60 years, it actually moves from patch to patch. And what that means is that the garbage problem is really an international problem.
It's also a problem that goes much deeper than floating plastic. The Monterey Bay Aquarium Research Institute in the US sent unmanned submarines to the ocean floor. and scientists have painstakingly counted every piece of rubbish caught on film. Plastic made up 32% of the rubbish they saw. From the depths of the sea floor to the garbage patches in the middle of our oceans, the problem of plastic is an ever-growing one.
So that means that even if we stop polluting tomorrow, this plastic won't go away. It will just stay there as a memory to what we've been doing over the last 50 years.